Hi guys, good afternoon. You are welcome to my channel. In today's class, we are going to be looking at likely exam questions in Physics 102. Alright, as we go through the questions, do not take them for granted because you are likely to see them in the exam. Alright, so the first one says E is measured in dash. E is measured in dash. E here represents electric field intensity. E is measured in, is it coulomb per meter, B coulomb per second, Newton meter, or volt per meter? All right, if we were to express the formula, we are having that E is equal to volt over what? Distance. All right, E here is electric field intensity, V is voltage, which is volt, then D is what? Distance. I told you guys that voltage means the potential difference between 2 points, all right, and it is measured in volts. The instrument used in measuring volts is called what? Voltmeter. I told you guys before. Now, if electric field intensity is equal to V over distance, V is volt, distance is measured in what? Meters. So the right answer to this question is option D. Option D is the right answer. Number two, the electric field at a point situated 4 meters from a point charge is 200 Newton per coulomb. If the distance is reduced to 2 meters, the intensity will be dash. Now, the electric field intensity at a point situated 4 meters from a point charge is 200 Newton per coulomb. If the distance is reduced to 2 meters, then if the distance is reduced to 2 meters, then the electric field intensity will be dash. All right, now don't forget that uh, electric field intensity, which is E, is inversely proportional to the square of the distance, radius. All right, so if I'm having this, I'll now be having E equal to K over what? R squared, right? And if I'm having this, I'll be having uh, K equal to what? E R squared. Is that what I'm going to be having? So if I'm having E R squared, it therefore means that I'll be having arrow E1 arrow 1 squared equal to E2 arrow 2 squared. All right. So that is what we are going to have. Now the first one here, we are given 200 Newton per coulomb. All right. So please let me remove this, please. All right. The first one is 200 Newton per coulomb. That is 200 times the first distance given is what? 4. So 4 raised to power 2, I have what? 16. Now this we are looking for this other one, which is the E2. All right. Then times they said the radius was reduced to what? 2. That is 2 raised to power 2. I have what? 4. I divide through by 4. All right. If I should do that, so 4 will go into 4. So E becomes 4 into 4 is 1. 4 into 16 is what? 4. 2 times 4, I have 8. Then 0, 0. So 0, 0 Newton per what? Coulomb. All right. So the answer is simply C. All right. C. Just use the formula F, that is E, equal to, that is E1 arrow 1 squared equal to E2 arrow 2 squared. Don't forget this formula. It's as easy as that. Number 3, dash is not a fundamental force. Option A, nuclear force. B, they're just like saying which of the following, they can say which of the following force is odd, or which of the following options is odd. Dash is not a fundamental force. A, nuclear force. B, frictional force. C, gravitational force. And D, magnetic force. Please, all of these force given, the one that is not fundamental is called what? The frictional force. Now, the frictional force is a force that exists between the surface of two objects, thereby opposing what? Motion. The frictional force is a force that is found between the surface of two objects. What does it do? It opposes or reduces what? Motion. And frictional force is given as the okay All right. So if you're having frictional force, if you're having the coefficient of friction, will be frictional force over normal force. It means that frictional force is a product of the coefficient of friction and what? The normal force. So we now have the nuclear force. The nuclear force is of course a fundamental force. All right. We have two types of nuclear force. We have the strong nuclear force and the weak nuclear force. The strong nuclear force is found in subatomic levels. The strong nuclear force is found in subatomic levels, while the weak nuclear force is found in radioactive entities. Okay, so take note of that. Of course, gravitational force emanates from the masses of objects. Magnetic force emanates from substances that undergo that exhibit magnetic properties. It's as easy as that. So the answer is simply B, frictional force. The next question is, EV is the SI unit of dash without options. EV is the SI unit of dash, okay? Now, EV that is electron volt, all right? EV is electron volt, EV stands for electron volt. Now, you should note that they'll ask you the total amount of energy that an electron stores as it accelerates through a potential difference in 1 volt. The amount of energy stored by an electron as it accelerates through a potential difference of 1 volt. The answer is electron volt. All right, electron volt is the amount or the quantity of energy stored, or that is kinetic energy stored to be specific, the amount of kinetic energy stored as it accelerates through a potential difference in what? 1 volt. That is EV, all right? Which means that kinetic energy is equal to what? QV. Our kinetic energy is 1 over 2 mv squared equals what? QV. Please don't take this for this. So you have to be very careful about that. All right. Now, this Q, it presents something. All right. Q represents what? The charge, elementary charge, and Q is equal to 1.602 times 10 to the power what? Minus 19 charge. All right. Take note of that. Sometimes sometimes they don't give you the value, so it's good you always remember this in case you are solving. You just slot it in and get your answer. It's as easy as that. So the SI unit of EV is the SI unit of what? Energy. All right, they'll give you energy. All right, they'll give you power. They'll give you one other useless option, work. All right, the SI unit, the fact that you see electron volts, okay, this electron volt, don't feel is you not take it to what's it called now, potential difference. Electron volt is the SI unit of what? Energy, just as we have illustrated, okay? Now, the fourth one, the SI unit of magnetic field is Tesla. The SI unit of magnetic field is what? Tesla. And this is equivalent to Newton second per centimeter, B, Newton coulomb per centimeter, then C, Newton per centimeter. So which of them is it? Oh, the answer is not even here. All right, we have it to be Weber slash meter what squared, Weber slash meter squared. All right. Oh, it's not so exact. Okay. Now the number 5, the algebraic sum of the current at a junction is 0. It's a statement of dash. The algebraic sum of the current at a junction is 0. It's a statement made by who? It's a statement made by Kirchhoff. Alright, so option C is the correct answer. Alright, it said that the current entering a given system, alright, a current entering a given system, it did something like this. Alright. This is Q3, this I3, and this I1, then I2. Alright, so the current entering into the system is equivalent to that is the one entering, All right, it's equivalent to the one leaving. So it illustrated this as 1 plus this equal to what? So the sum of the I1 and I2 is equal to what? The one leaving, all right? Meaning if I should express this further, I'll be having I1 plus I2 minus what? I3, all equal to what? 0. So the algebraic sum of the currents at a junction is 0. It's a statement made by what? By who? Kirchhoff. Now, the what's it called? Now, the Gauss law only explains the electric flux, all right, of a charge in an enclosed system. Do you understand? Take note of that. Then Hess law is used to compare the densities of two liquids. All right, Hess law is used to compare the density of two liquids. So please take note of that. And Hess law is giving us density 1 at 1 equal to density 2 at what? 2. So this is what Hess law. It compares the density of two liquids. Density 1 and density 2, distance 1 and distance what? 2. Then Ohm's law, the law states that the electric current that passes through a metallic conductor, all right, is directly proportional to the potential difference across its ends, right, provided that the temperature and other physical quantities are kept constant, all right, and it is shown as V equal to what? I arrow. Why? V there is potential difference, I is a current in ampere, and R is what? The resistance. I told you guys that the word V is potential difference and it's measured in what? Volts. And volt is also the SI unit of what? Voltage. And voltage is the potential difference between two ends. The instrument used to measure voltage is called voltmeter. The instrument used to measure current is called ammeter. The instrument used to detect the presence and the direction of small currents is called galvanometer. And the instrument used to measure potential difference is called potentiometer. It's as easy as that. Don't forget that in our previous class, I told you something, that when voltmeter is converted to ammeter, a low resistance shunt in parallel is used. For a galvanometer to be converted to ammeter, a low resistance shunt in parallel is used. But for a galvanometer to be converted to a voltmeter, a high resistance multiplier in series is what used. Do not forget that. So we've analyzed the questions we have on the board. So let us look at other questions. All right, we'll be very fast about it. All right, so they're asking us, and they said, look, listen to the question very well. They said the magnitude of a magnetic force, acting on a charge Q depend upon the following, except the magnitude of a magnetic force acting on charge Q depends upon the following, except option A, they said charge, which is Q, B, the speed of the charge, they use V, C, electric potential for the charge, V, and D, magnetic field intensity, which is what? B. Now, don't forget that in the option they repeated two V's, and one of the V's was for velocity and the other V was for potential difference. And please, magnetic force is given as QVB sine theta. All right, so this Q is the charge and V is the velocity of the charge and B is the magnetic flux, or magnetic flux, and sine theta is the angle inclined. And magnetic force is also given as BIL, then sine what? Theta. All right, B is of course the magnetic flux, I is current, and this other L is what? Distance. All right, and please, you should note something. When V and B are parallel, take note of that. Take note of what I'm about to say now. When the velocity and B are parallel, the angle inclined is usually what? 180 degree, or what? 0. It therefore means that the force is what? Minimum. Minimum, alright? When V and B are traveling towards the same direction or are parallel, alright, the angle inclined is what? 180 or 0. It therefore means that the magnetic force is what? Minimum. But when V and B are perpendicular, when they are perpendicular, to each other, the angle inclined is what? 90 degree. Therefore, the force is what? At its maximum point. Alright, so don't forget what I just stated. So, in the question, they gave us option A as the charge. It says the charge of the is the charge. Yeah, it's a charge. Then B, they said the magnetic flux. They give us magnetic flux, that is B. Then the C, they gave us another V, stating the potential difference of the charge. And D, they gave V again, which is the speed of the charge. So the one that is odd in this question is what? C, potential difference. And as you can observe, we don't have anything like potential difference in the formula. We only have velocity, the speed of, that is velocity or speed of the charge. Then we have the charge itself and the magnetic flux. And sine theta is the angle inclined. All right, the next point, the next question is, I believe you are following. Okay, now two equal and opposite charges separated by a distance is referred to dash. Two equal and opposite charges are separated by a distance is referred to as what? A. Now, two opposite equal, that is two equal and opposite charges. Two equal and opposite charges. Alright, when a compound is having two opposite charges, alright, which means one is negative and the other one is what? Positive. Alright, that is, we call it what? Dipole. We also refer to what? Polarity. Alright, and water possesses that H plus and what? OH what? Minus. Alright, so two equal and opposite charges separated by distance is called what? Dipole. Alright, it's called what? Dipole. Take note of that. We have dipole, we have dielectric. I told you guys while we are treating the capacitors and capacitor and dielectrics. I said dielectric is the insulating material placed between two metallic substances. Alright, so dielectric. Alright, now option C, they gave us dipole moment. Dipole moment only measures the strength and what? Direction of the question, of the substance in question. Alright, so dipole is two equal and opposite charges separated by what? Distance. The dielectric is the insulating material placed between two metallic substances. So the answer is what? Dipole. Take note of that. Then the next one, they said any electric field is said to exist at any point in space when an electric field is said to exist at any point in space when A, two charges attract each other, B, two charges repel each other, C, a test charge experiences an electric force, and D, a test charge is what? Attracted. What is electric field? Electric field is a region is a region within a space where electric force is what? Experience. Alright, so they asked me, said the electric field is said to exist at any point, alright, when a charge experiences what? Electric force. So the answer to this question is what? Option C. Alright, then the next question, the relationship between the electrostatic force of attraction or repulsion, they gave Fe between two charged bodies, and the separation between them is explained by dash. A. Gauss law, we have explained that. B. Kirchhoff's law, we have explained that. Coulomb's law, we've not explained that. And D. Ohm's law. So the answer to this question is option C, Coulomb's law of electrostatics, which states that like charges repel and like charges what attract. It also stated that the force of attraction or repulsion between two charges, all right, is directly proportional to their products, and inversely the square of the distance that separate them apart. All right, this law states that the force of attraction or repulsion between two charges is directly proportional to their product, and inversely to the square of the distance that separates them apart. All right, so F is equal to KQ1 KU2 over what? R squared. All right, please don't take electric potential for what I'm doing right now. Electric potential is just giving us Q over 4 pi E naught arrow. All right, not arrow squared, it's just what? Arrow. Take note of that. And please don't, I believe you also are aware that K is equal to 1 over 4 pi E naught. All right, then E naught stands for what? Permittivity. Permittivity in what? Free space. And E naught has its value as 8.85 times 10 to the power minus 12, then Coulomb square per Newton, then per meter what? Squared. All right, 8.85 times 10 to the power minus 12 per Coulomb, that's Coulomb squared per Newton per meter what squared. So take note of that. The statement is attributed to Coulomb's law of electrostatics. Now the next question. Now, they said the next question is actually long, but if you know what you're doing, you don't have to read everything. Now, the Kirchhoff's law current states that A. The algebraic sum of all potential drops across the passive elements of a closed circuit is equal to the resultant EMF in that circuit. Option B. The algebraic sum of all potential difference drops across the passive elements of a closed circuit is not the same as the resultant EMF in that circuit. Option C. At any junction of the electric circuit, the sum of all currents entering into the junction, I explained that before, into the junction must be equal to the sum of all currents leaving the junction. So you don't have to read further. The answer is simply A. At any junction of the electric circuit, the sum of all the currents entering into the junction, all right, must be equal to the sum of all the currents leaving the word junction. So please take note of that. Don't forget that the Kirchhoff's law is what is stated in option B. All right, option A. That is, you should know that Kirchhoff's second law is also called law of what? Voltage. Law of voltage. And please note that Kirchhoff's current law is governed by the law of conservation of charge. Take note of that. Kirchhoff's law of current is governed by the law of conservation of charge. Okay, and the second law states is here the sum of the algebraic sum of all potential drops across a passive element of a closed circuit is equal to the resultant EMF in that circuit. So take note of that. Okay, now you see, I just look at the next question. Kirchhoff's current law is based on A. The law of conservation of energy, B. The law of conservation of momentum, C. The law of conservation of charges, and D. None of the above. The answer is C. The law of conservation of charges. At this point, we call it a day. If you have learned something in this video, endeavor to subscribe, like, share, and comment. Do have a wonderful day.